So let's get into the number systems now. You may be wondering why we are discussing the number system, especially the decimal numbers which I'm showing on the screen now. Okay, so here is the background. So in the digital communication, including the networking or data communication as you may call, the machine understands only zeros and ones, right? It's like a presence of a signal or absence of a signal. Now for any one of us, like, to analyze or interpret or even configure, dealing with binary numbers is difficult. Why? Because the identities like IP address, MAC address, IPv6 address, subnet mask, wild bit mask, all these numbers are pretty long numbers. Like IPv4 address is 32-bit, MAC address is 48-bit, IPv6 address is 128-bit. So it's very difficult for humans to really understand so many ones and zeros and then try to analyze what address it is or what subnet mask is, and all the more difficult to use them and configure them. So as a result, what happens actually is we tend to prefer, if those numbers are somehow translated into decimal numbers or hexadecimal numbers, it makes our job easier. So human preference, as a network engineer, our preference is that let the machines understand ones and zeros, but when it comes to my interpretation, or if I want to configure it, I would rather be comfortable using decimal or hexadecimal numbers. So that's the reason the importance of this topic is that we understand that numbering systems and how do we translate from one to another, and do a bit of a practice, because let me tell you, a lot of mistakes can happen, and mistakes do happen when we think that the any calculation or any subject is easier. So wherever things are easier, we tend to make mistakes, and mistakes can be costly. So whether it is like what do you call an exam like a CCNA or CCNP exam, or it could be any task which you are doing right in the job. So let's start with decimal numbers. As we know, the decimal numbers are of 10 numbers. If you include 0 and 9, there are 10 numbers. That's the reason the decimal name into consideration. If I see an example like 4386 here, 4386 here, I need to notice that there is a value for each digit, right? The value is like 6 or 8 or 3 or 4. And these numbers vary from anything between 0 to 9. Now that is the value of the digit here, and then there is a weight of the digit here. So from our childhood, we know that this is units, this is tens, this is hundreds, and this is thousands. Okay. Now I take the weightage, and if I multiply with the value and I total them, I get the total number. So this is how it goes. So you have like at a unit 6, the value of the digit is 6, and the weightage is 10 power 0, which is 1. Anything to the power of 0 is 1, provided it is a number. Now I have the value digit is 8 and the weight is 10, so I have 80. I have value 3 and the weight is 100, so I have a 300 here. And I have a value of 4 and then weight of 1000, it is 4000. When I add this, it is 4386. So whenever we look at any digit, two things we need to remember. Understand the value of the digit, which depends on the decimal number. Since decimal number supports up to 9, which is totally 10 numbers, it will be any one of them. Depending on the position of the digit, you multiply with the weight. And when you add the value, you'll get the total number. Of course, here I am converting a decimal number into a decimal number, but my point here is I'm emphasizing the importance of the value of the digit and also the weight of it. Some numbers are pretty huge, some numbers can be managed with the decimal itself, but MAC address like 48 bits or even IPv6 address is 128 bits, they're pretty huge numbers if I deal with binary and also deal in decimal. So we have no choice but to go for a hexadecimal numbers. So what is the hexadecimal number? Hexadecimal number has 16 digits, 16 values rather. So you have 0 to 9 exactly same in both decimal and hexadecimal. Then after 9, the decimal tends to take 2 digits, right? Because 9 is the maximum number possible. So you have 10, 11, 12, 13, 14. Whereas in hexadecimal, they continue to be a single digit. So you have A, B, C, D, E, F. So with this 60 numbers possible, if I look at a sample value like here 9AEF, so I've shown the values in hex and I've shown the values in decimal. So 9 is a 9, so we are seeing it here. A is 10, okay. E is 14, and then F is 15. Now, I know from my previous discussion that these digits have a value, but depending on their position in the number, they have a weight. So the first one is 16 power 0, which is 1. Second one is 16 to the power of 1, which is 16. Then you have 16 to the power of 2, which is 256. And then finally, 16 to the power of 3 here, 4096. So I follow similar method what I followed in decimal. I'll take the value. For example, here I'll take 15 value and then multiply with the weight. So 15 into 1, that is 15. Then I take E, which is 14, into the weight, which is 16. So 14 into 16 is 224. If I take the third one, the value is 10, and then my weight is 256. So 2560. And then finally, if I take 9 and then multiply with the weight at the fourth place, which is 4096, I get 36,864. And when I add all of them, I get 39,663. Now this is the decimal equivalent. By the way, all these are decimal values, but that's what we are comfortable at, right? So a number 9AEF, if I translate into decimal form, it comes to 39,663. That's quite high. Imagine if all are F, that means the maximum value that is allowed is 15 in decimal. If I take 15, 15, 15, then what will happen? All of them are 15, that is F. 15 into 1, 15 into 16, 15 into 256, and 15 into 4096. That becomes a bigger number. So whenever you come across a number which is quite huge, even for a decimal number to represent, then we resort to hexadecimal format. So depending upon the number size, you would like to see whether it is a decimal or hexadecimal makes sense. Okay. So later when I do the IP subnetting and all that, so you have basically a chance to look at some of the numbers and why we choose hexadecimal and sometimes and why we choose decimal. The next number system is binary. We can't ignore because that's how we ignore this because that's how the machines understand. So you have only two numbers. And then if I take a sample number like 1010, you see the value of the digit here either 1 or 0 because only two numbers possible. So that's what makes somewhat easier to get the value. Suppose I say 1010, the weightage is 2 power 0, 2 power 1, 2 power 2, 2 power 3. Why 2? Because only two numbers possible. In previous hexadecimal, why 16? Because there are 16 numbers possible, right? If I now convert that, it is 0 into 1, so you have a 0 into 1 here, you have 1 into 2, and then 0 into 4 and 1 into 8. See here either you have a 0 and 1. So one way to see is take all the weightages which has a 1 above on that and then add them. So 8 plus 2, that is 10. Suppose if I convert slightly longer number, like for example 8 digit here, so I have a number which is 10010110. So first of all, I put the weights below it. So 2 power 0 to 2 power 7. So that comes to 1, 2, 4, 8, 16, 32, 64, and 128. Now I take where all ones are there. So I have 128 here. So I'll take that one. I have 16 here. I'll take that one and add it. So 128 plus 16 is 144. Then I take 144 plus 4, which is 148. And then I have 2, which is 150. So this is 0, I won't take it. So what happens now? I take 128, I take 16, which is 144, 148, and 150. So if I convert this 8-bit decimal binary value, I get 150 as a decimal. So this is binary to decimal conversion. So here I take an IPv4 address, which is a 32-bit number split into 4 equal parts. And then what I do is I take each of these equal parts and then convert them into decimal separately. Like for example, if I take this number, this is 128, I don't take 64, then I take 32 and 16. So 128 plus 32 is 160, 16 is 176, and then I have a 4. I'm just adding the weights, right, as you seen in the previous slide. So as a result, what will happen? This becomes 180, 128, 32, 160, 176, and 4, 180. Similarly, this one, this is 128, this is 16, so which is 144. Then I have a 4, which is 148, and 2, 150. So that's the 150 here. Likewise here 128 and then 64, 192 and then 194 and 195, right? So this is 2 and 1. And the last one, which is 64, then I have 16, which is 80, 88 and then 290. So that's how I convert. So binary to decimal conversion, decimal to binary conversion is something which happens regularly in the networking technology. Now let me come to the other way around. So far we have seen how I have a binary, I converted into decimal. Now I'll convert decimal back to binary. Suppose example, I have a number called 95 here. Immediately I'll just list down all the weightages. Okay. So you can see here for an 8-digit, the weightages go for 1, 2, 4, 8, 16, 32, 64 and 128. Now, because it's a binary, all that I have the values of any binary is either 1 or 0. That means 0 means I don't consider that weight. If it is 1, I do consider that weight. Now, one simple way, if you are fast enough in mathematics, what you can do is you can just pick the numbers which are these weights which can constitute this 95. For example, readily I'll say that I should take 64, then I take 16, so which becomes 80, right? Then I take 88, okay? Then this becomes 92 if I keep adding, and then this is 94, and then finally 95. Now if I'm not comfortable that way, there is an orthodox method, there is a simple method, and I suggest that if you are doing this for the first time, or maybe if you don't have a practice of quickly putting together numbers, follow the orthodox. There is no problem, you can do that. Idea is not to make a mistake, so don't feel that you are using too primitive a method. Do it simple way. Now how do you do it? So I look at the number and look at these weights, okay, and I'll pick the maximum weight which is either equal to 95 or less than 95. So I don't have anything equal to 95, so I have to take the less than 95. So 64 is the highest weightage which is less than 95. Of course 128 also is highest weightage, but that is not less than 95 or equal to 95. It is more than it. So I take 64. I deduct 64 from this, I end up getting 31. Now when I get 31, so I'll put a 1 below the 64 because I'm using it. The balance is 31. The highest weightage which is equal to 31 or less than 31 is 16 here. So when I deduct 16 from 31, I get 15. So then I'll take 8, then I'll take 4, then I'll take 2, then I'll take 1, right? So whichever I'm taking, I'll put a 1 below. So it goes like this. So I took 95, I deducted 64, I got 31, then I took the next weightage 16, then I got 15, then I took 8, I have 7, then I took 4, I got 3, then I took 2, I got 1, and I took 1, the balance is 0. So till this number is reduced to 0, I keep on picking the weights which is either equal to or less than that maximum out of it. So as a result, the number will be like this. So I took 64, 16, 8, 4, 2, 1. It's simple. If you do practice, you can do it really fast, right? Okay, so let's look at the decimal to binary conversion of a slightly larger number. So that is basically an IPv4 address, which is 172.168.100.150. If I go by same calculation what I did earlier in the slide, my 172 turns out to be 10101100, 168 is 10101000, 100 is 01100100, and then 150 is 10010110. So let's quickly cross check. So this is 128 for me, the weightage. So 128 is there, no 64, 32. So 128, 32 is 160. 160 is 168 plus 4. Okay, it is 172. If I come here, this is 128, no 64, so 32, so 160, and no 16, so 160 plus 8, so that is 168. Now I have 64 and then 32, 96, and then 400, so that is 100 here. If I see here, this is 128, so this is 16, 144, then I have a 4, 148, and 2, 150. So that's how it is. So take the decimal number, either you see the collection of the all the weightages put together, which collection of weights that constitute this number, you can put zeros 1 accordingly. Otherwise, you can use that subtraction method what I showed earlier, right? Now, if I want to convert a hexadecimal into binary, trust me, hexadecimal into binary. So what happens is I need to take digit by digit. Because hexadecimal, if I consider whole number, can be very big. And then converting that into decimal and then changing decimal into binary, I'm not saying it is impossible. Nothing is impossible. It is okay, but it may take time and chances of mistakes are higher. So easy way to convert any hexadecimal into binary actually is you take each digit and then convert it into a 4-bit binary. Suppose I have a 4. Decimal also is 4, so I convert this 0100. So 8421, so I took 4 only. Similarly, if it is C, that is 12, then I can say 8 and 4 plus 12, so that's what it is. Suppose if I have 2-digit number, you separate them out. Take 2 separately, take D separately. So 2 is 2 only, D is 13. Convert 2 into 4-bit binary and convert 13 into 4-bit binary. So 2 is 0010, 13 is 1101, 8, 4, 12, 12 plus 1, 13. Similarly, if I take an E5, it is 14 and 5. FF, it is 15 and 15. Each digit is separately converted into binary. This is the easier way. You can take, I'm not saying don't take it. For example, if I take F and F, if I put the weightage in hexadecimal, this is 16 power 0, this is 16 power 1. I say 15 into 1 and 15 into 16. I add them the way I added earlier, convert into decimal and then convert the decimal into binary, you will get exactly same. You can try it out. But the easier way in hexadecimal is take digit by digit, convert each of them into 4-bit only. For example, if I have 0 anywhere, it has to be 00004 4-bit binary. You will see in then my next example, which is nothing but an IPv6 address. You see how many hexadecimal digits are there? There are 32. So each is a quadrat, so they have 4, 4, 4. So if I want to convert this into binary, I have to take each hexadecimal bit and convert into 4-bit binary. For example, there is an F, all ones, that is 15. I take E, that is 14, so 8421. This black stuff is E. Then again the blue stuff is 8, 1000. And then you see 0 here, I made all zeros. So accordingly, if you observe all these digits one by one, you will see that each of the digits has been converted into a 4-bit binary. So that's how the number system, it's a very short video just to make you once again look at the number systems, whether it's a binary, whether it's a decimal, whether it's a hexadecimal, and somewhere all the binary numbers need to be converted into one of them, or the hexadecimal and decimal need to be converted into binary. And the importance of this, you'll see, you'll feel heavily in the what you call in the IP subnet map. So I'll sign off this here, and then in the next video we'll talk about some basic understanding of any network connectivity and also TCP/IP model. Okay, thank you.